Good evening. I'm Julian Rodriguez, Dean of the School of Media at the London College of Communication, and I extend a warm welcome to you all at the second of this year's University of the Arts London Professorial Platforms. I think I always sense deep inside that behind the boredom of the Friday afternoon physics lesson lay profound questions about physical matter, time and space. But the beauty and magic of, for many people, a less comprehensible branch of science were mostly lost to me until last year, when privileged to be a guest at Stanford University's breathtaking Linear Accelerator installation, SLAC, in California with Ken McMullen. I came to realise that complex concepts behind advanced physics are far from impenetrable, can be beautiful, and with the help of Ken's power of elucidation through art, film and words, for this student at least, graspable. I also came to appreciate how the rule-breaking, risk-taking, leaps of imagination and expecting the unexpected that are all essential parts of cutting-edge physics are the very same leaps and bounds that make creative artists and filmmakers tick. The point of connection is often that insistent search for new knowledge and the satisfaction derived from those special eureka moments. Ken McMullen has been working with physics labs since the year 2000, producing moving picture works and artworks inspired by contemporary physics. Ken has produced works at the European Centre for Nuclear Research in Geneva, CERN, where the concept of the World Wide Web was born to enable physicists to communicate and exchange ideas across the globe, and more recently working at SLAC's installation in California, where they are now constructing an ultra-fast camera capable of capturing the crashing moments of subatomic particles, a kind of molecular movie with the objective of helping visualize what the Big Bang might have looked like. Interestingly, Ken's background is not in science, but in painting, and his approach to cinema is unique. His motion pictures include Xena, which revolves around the complex and tragic life of Trotsky's daughter, Partition, which explores the folly behind the borders drawn during the partition of India, and Ghost Dance, looking at life, death and the possibility of ghosts. Ken's films are highly respected for their painterly feel, through which palpably threads Ken's quest for understanding the big questions of life. It is cinema where human drama, ideas, concepts, beliefs and new knowledge matters. Described by Derek Malcolm as our secret auteur, Ken McMullen's motion picture work is at home in the cinema, in the gallery, the science auditorium, or writ large on the walls of a nuclear power station. Ken has collaborated in his film and artwork with John Berger, Derek Jarman, Jacques Derrida, performance artists Joseph Beuys and Stuart Brisley, and experimental and theoretical physicians Michael Dosa and John March Russell. Ken continues with his experience, experimental approach and unique vision for cinema to inspire and enthuse students on our undergraduate course at the Media School, and we're very thankful for that. Tonight, we're very privileged not only to see Ken's work, but to observe him almost as if in a studio. But here for us, presenting live cinema, not according to a fixed plan, but responding to emotion, intuition, and improvisation on this particular night. The hope is that the presentation tonight explores how information is put over, how science, art, and education can combine, and to push on the boundaries of what we think of as a university professorial platform. Before Ken begins his work, we're going to see his short film 1867, which has been specially requested to start this event. It combines art and cinema and the concept of time in a very direct way. The film, a totally resolved and self-contained piece of work, unusually consists of just one take, no edits, just 1,000 feet of film running through the camera uninterrupted, and as it does so, compressing the 18 months struggle that engaged painter Edward Monet as he attempted to resolve and do full justice to one moment in time, the most significant moment in the life of Emperor Maximilian of Mexico, as triggers were pulled at the puppet emperor's execution. Ken's film flickers in and out of the painter's mind, where the anxieties of seeking to live up to his own expectation for his art and his predecessor's Goya's brilliance results in a struggle, the type of painful struggle from which great art can triumphantly emerge. Immediately following 1867, Neil Calder, one of the world's finest communicators on the highly abstract world of high-energy physics, the one that I only just try and understand, who has worked for both CERN and SLAC, and now for ITER, the International Research and Development Project, which is exploring the possibilities of fusion power, will further illuminate the richness of Ken McMullen's approach to cinema, collaboration, life, and the universe. Ladies and gentlemen, before we begin, would you please turn off your mobile phones, and we'll start with the first screening. Thank you very much.
Le Figaro, le 8 juillet 1967. Les prisonniers partirent pour le lieu d'exécution à 7h du matin, le 19 juin. Le cortège grimpa la colline qui mène à la place. La route fut fermée pour empêcher la foule de suivre le cortège sur la colline. Seulement quelques témoins furent admis. digne de la grande peinture historique pour le salon. Ma composition montrera un acte unifié, symbolique, solennel et héroïque. De penser à cette image du 3 mai de Goya, la mort terrible de paysans, les fusils du peloton d'exécution si près de leurs victimes. Ma peinture aura une similitude avec celle de Goya. Dans la sienne, l'exécution de paysans. Dans la mienne, l'exécution d'un empereur. Tous les jours, j'apprends de nouveaux détails par le Figaro. L'empereur est mort avec 2 généraux loyaux. Je vais prendre mon ami violoniste pour le général Méramont. Un modèle professionnel pour le général Méja. Mais pour Maximilien, je me servirai d'une photo. Mais les victimes sont trop près du peloton d'exécution. Il n'y a pas de sentiment de distance entre les deux groupes. L'effet de l'exécution est perdu. Je dois abandonner cette composition. Un escadron de soldats français fera le peloton d'exécution. Nous devons le considérer comme la France assassinant son empereur pantin, Maximilien du Mexique. Il faut comprendre la trahison de Napoléon III. La ruine de ma deuxième tentative. Quatre tentatives. 1 an et demi. Pour peindre un seul instant. Combien dure l'instant d'une mort violente? Se peut-il qu'un tel moment échappe au temps lui-même? Mais qu'allait donc faire cette marionnette impériale au Mexique?
Herkünfte meines Ranges, bewegt von Gefühlen wie ich, sind von Schicksal ausersehen, entweder Glück ihrem Volk zu bringen oder zu Märtyrern zu werden. Ich wurde verraten, betrogen und beraubt, am Ende gar für 11 Silberlinge verkauft. Mexikaner! Mexikaner! Möge mein Blut nicht umsonst fließen. Möge es meine unglückliche Wahlheimat einem besseren Leben zuführen.
Neil, would you like to come forward?
Can you hear me if I speak here? Yeah, that's good. Good, well, good evening. I'm very pleased to be here. My name is Neil Calder. I've had the great luck over the last 20 or so years to be responsible for communicating the work that goes on in some of the great physics labs around the world. My training is entirely in English literature. I understand if I had a deep fear about physics, but I went through a period where I suddenly realized that science is not only deeply interesting, it is also very easy to understand up to a mathematics barrier, and also that it is profoundly significant in the age we live in. And some of the happiest moments in this career have been spent with Ken working together on some really fascinating projects. Just a general reflection. Last year, I left Stanford University after 6 happy years. I happened to come across the entry examination papers for Stanford for 1907. And I was looking through these papers, and was amazed to see that something like 75% of the questions that these students were being asked in 1907 were to do with the classics. It was Latin, it was Greek, it was ancient history. There was a little bit of history, literature, tiny bit of mathematics. Now, nearly all those subjects which were held to be of the greatest importance only 100 years ago have now completely disappeared from the academic curriculum. What will it be like in 100 years' time from now? That we are going into an age, we already live in an age, which is really completely dominated by technology and science. And one might say that the truly big intellectual challenges of our time are in the sciences. How is the world of literature, how is the world of art going to react to this huge tidal wave of pressure coming from the sciences? I'm not sure, but I certainly know that Ken McMullen is one of the people in the world who has made a really significant effort to see in which way these two traditions can work together. Ken and I started working, I think in 2007, we first met in Geneva at this huge physics lab called CERN. And Ken really came up with the idea of creating a project where we would invite 12 of Europe's leading contemporary artists to CERN to produce a body of work which was reflection on what was going on in particle physics at the time. And this was an intensely enjoyable and very, very interesting experiment. It was the first time anything like this had been tried. And the work that was produced, the body went on to form an exhibition which was called Signatures of the Invisible, which then went to London, Geneva, Rome, PS1 in New York. It's basically toured around the world and was really a groundbreaking event in this kind of work. It also provided me with one of the most bizarre conversations I've ever had with a French artist called Jérôme Basserode, who, as part of his contribution, he made these big spheres out of steel. And I said, Jérôme, what are those things? And he said, those are my balls. And I said, no, round objects. And he said, who's round? Why does he object? Anyway, after CERN, where Ken filmed a lot of very, very historic interviews, we then went to Stanford together, where Ken continued his work of talking with the major physicists. I think we should realize that we are lucky to live at a time which is a complete change, a paradigm shift of how we understand physics. That this year, in a few months, the Large Hadron Collider, which is a huge particle accelerator, will turn on in Geneva and will definitely give results which will completely change our concept of how our universe functions. That in the last 5 or 6 years, we've had this major shock. You probably remember Keats. He has this one image of stout Cortez climbing with his men to the top of a mountain in Darien, expecting to find a golden city below. But when he gets to the top of the mountain, he looks out, and what does he see? The Pacific, something completely unexpected, which they never thought was there. And the world of physics is in the same state as stout Cortez. We're standing around looking amazed by what's happened, because it's become very clear in the last 5 years that all the science we've ever done, all the physics we've ever done, only relates to 4% of the total mass of the universe. That 96% of the mass of the universe is made of stuff which we have no idea what it is at all. We are a tiny, tiny minority of what is going on. And all our science from the beginning of time only relates to 4% of the totality. And this is pretty disappointing for physicists, because we thought we got it more or less sewn up, but we realized that we're just beginning to understand. The Large Hadron Collider in Geneva will probably give us answers to some of these questions of what the universe is made of. I'm going into some detail about this because one of Ken's work, which you'll see, called Lumen de Lumine, which is a film made at CERN in a particle accelerator, which shows a young woman swirling a light around her head. And it's an image of almost complete blackness, occasionally illuminated by this light that goes around. This film was made before the whole concept of dark matter, dark energy really came into current credibility in the science world. And it always struck me that this film is the perfect illustration of the whole concept of dark matter, dark energy, the dark universe. And yet it became before. And I think it's a characteristic of really great art is its ability to predict the way society is going to go, to predict the discoveries of the future. And this work of Ken, I think, is really striking for that he, I don't know, intuitively or in some way understood or certainly represented a vision of the universe which is extremely modern, which we now have. At Stanford, Ken had the courage to go and talk to some of the truly great scientists of our time. And I've always been deeply, deeply, deeply admiring of Ken's enormous energy. He can stay up all night. He forces me to stay up all night talking about physics. And then the next day he comes back as fresh as can be and will then spend 8 hours speaking about concepts which are really mind-boggling and difficult with these scientists. And yet he never is tired by this. He comes back over and over again to really try and understand profoundly the meaning of these advances in theoretical physics. You'll see two historic interviews here. Mike Peskin is the head of theoretical physicists at Stanford, one of our great scientists, and you'll see an interview of Mike by Ken, and then Roger Blanford, who is again world-renowned particle astrophysicist, is interviewed by Ken on this film. So I am very interested to see what will happen. I saw a version of this film in San Francisco. It was at the San Francisco Film Festival in August last year, but I know it's now developed greatly and probably even better. So let's hand it over to Ken. And Ken, my personal thanks for a wonderful ride over the last 10 years. Thank you.
Thank you very much, Neil. Yeah, I think you kept me up all night, actually. I'm not sure it was the other way around, but nevertheless, there were some fantastic discussions. And Michael Peshkin, Neil warned me, he said, when you go in with Michael Peshkin, nobody goes in coming out with a headache, I think you said. Everybody comes out with a headache. And I did have a headache, it's true, because trying to follow it is pretty heavy stuff. There's an extract of this in the timeline. The timeline we're going to look at, which is a new work, and we're trying to piece it together now. In a sense, you've come in literally to the studio situation with collaborators here. We've been trying to bind together a timeline which brings an association between, obviously, artistic practice, science, particularly in this case physics, philosophy, contemporary philosophy, and literature, poetry. And it was my view that there was an excessive compartmentalization of these different disciplines, perhaps necessary, but nevertheless, it seemed to me that there may be some correspondence, and that correspondence should be explored. And that's basically what this timeline is. It's 1 hour of a series of what might be called envelopes. I don't want to talk too much inside the film. I will give some signposts as to what's coming, but not very much. But basically, you're seeing a juxtaposition of different envelopes from different disciplines. And they're handled in different ways, and the use of film is different, and alternating from digital from analog, and some kind of juxtaposition of these and synthesis of these. And really, it's an attempt to find a new kind of work. It's been called live cinema. It kind of is live cinema. Sometimes it's chaos cinema, we don't know. But anyway, we're going to see now. So I'll need now the projection up, and we can begin, I think. Okay. The first piece, the first envelope, is extracted from Milton's poem on time, where he perceives time as a thief, but taking only what is effectively mortal dross. Written in 1631, I think. The next envelope is a piece of diary footage taken at SLAC in California, and we are really looking at observations of the universe and the notion that galaxies, a series of galaxies, collided at a point in time closer to the Big Bang than today, and this event has only really come into consciousness now due to the kind of new information.
What happened is that in the past we actually had two clusters of galaxies, and they all contain galaxies, hot gas and dark matter. Now what happened is these two clusters of galaxies collided, and they collided with really high velocities, which is 4,000 kilometers a second, not kilometers an hour, kilometers a second. And so because they collided, what happened is you had the galaxies which collided, but they're so rare in a sense that they barely saw each other. So the galaxies went straight through. So now this is 1 and this is 2. The galaxies went straight through. The gas, however, behaves like a fluid. And so if you kind of imagine two streams of water coming together, what is going to happen is going to create all sorts of turbulences and mixing and motion. And so that's why the gas sticks in between. It slows down and sticks in between. And if dark matter were behaving like a fluid, it would slow down and stick as well. However, what happened is that dark matter is not behaving like a fluid. It's not behaving like the particles we know on Earth. It's completely collisionless, and so it goes straight through. And so what we ended up with is two concentrations of dark matter with a bit of galaxies and a gas in between. And this is what made this cluster so extraordinary, because looking at it, we didn't see, like in a regular cluster, you see the effects of dark matter and gas piling up on each other. However, here in the bullet cluster, you see them clearly separated, so you can study individual effects.
The next envelope is a piece of experimental cinema, which juxtaposes material shot in 1971 with material just shot recently in Los Angeles, shot in the same situations in Los Angeles. The idea is to explore overlaps between these different forms of production, looking towards a synthesis in the future for a new kind of narrative possibility.
Minutes where you have your coffee break in the morning, or it can be the whole life of the universe and how it evolved.
You use different time measurements and different speed measurements because you're dealing with such infinitely greater measurements or infinitely smaller measurements. To use miles per hour doesn't really make sense.
Exactly, because the numbers get too big for us. That's why we kind of adopted different units. We adopted kilometers a second, which I would never use in everyday life because nothing that I really experience on an everyday basis is really moving in kilometers a second. My car doesn't go that fast anyway, so.
The only evidence left of those moments was some scratched and grainy film. Film that had caught those slivers of time before they vanished into the abyss. To retrieve them and put them in their rightful place meant peering deep down into the nucleus of this neon social slum.
The man was found dead on a downtown LA street, and now police are trying to figure out exactly what happened. Investigators say they are not sure if it's a case of deadly hit and run or murder. The victim was found near several parking lots at the corner of Santa Fe and Banning early this morning. Police say he had major trauma to his body.
Way down, where time itself fragments into a dark soup of unknown particles.
Something has happened in the last 4 or 5 years that will only happen once. Suddenly scientists have been able to say that they now know what the universe is made of. 4% of the total mass of the universe is made up of visible matter. What this means is all our physics, all our science since the earliest days, all of that only relates to 4% of the total mass of the universe. There is about 24% dark matter, and this is far beyond actual stuff. It's particles. But the vast majority of the mass is this stuff, dark energy, which we know 0% of our knowledge of science. And so we now have a completely new vision of how the universe works.
Something was out of sync on the streets of LA that summer. Some roads led to the bright lights of the Strip. Some roads seemed to lead nowhere.
Matter is a very generic term. So basically, if you ask me what dark matter is, I can give you some sort of ideas which we have at the moment of the way I explain it. It's probably made of elementary particles. If you ask me what visible matter is, I can tell you in galaxies it's mostly hydrogen, things like this. So matter is a little bit of a generic term.
Over at Barney's Beanery, a crowd of bums reported hearing a dark soliton.
I would like to get some sense for what a dark soliton sounds like. So what's a dark soliton? It's not the same, but it's not sure it's not and it's quiet. And they're all phased together so that the noise will happen at once. That's what it means. If you spectrally decompose all of the sounds in that track, what happens is that they're all, waves and they all have a different phase with respect to each other, except right where the clap happens in time. So, what does that look like in time? Does that look like the delta function? Different. What it looks like is something that turns the whole thing takes the ball. Sound. is what's called the dark solitime.
If you want me, darling, take me how you can. I'll be circulating, 'cause that's the way you gotta get me, 'cause I can't get the left unless I got room to move.
Behind those gates, the story began to unlock. The shots had been fired at the same moment those slivers of time went missing. The weapon was a recent acquisition registered in 2001 down at O'Shea's in Wiltshire. But the marks on the bullet casings match records from the Beanery incident back in 1971.
This next envelope is extracted really from Pessoa's writing, Fernando Pessoa, the Portuguese poet, and basically suddenly the title suggestive that concepts that we may hold as unshakable can suddenly be replaced with new insight. And this is a reflection really on the world of contemporary physics, written in the 1930s.
Suddenly, as if magically operated on for an old blindness, with great unexpected results, I raise my head to understand clearly how I have existed. I see that everything I have done, everything I have thought, everything I have been is a kind of illusion and madness. I'm amazed I never could see it. All that I was, now at last I see. Suddenly singes it all and consumes everything. It leaves me naked, far away from myself. It was all just in a moment, the smallest quintessence of time. Suddenly, as if magically operated on for an old blindness, with great unexpected results, I raise my head to understand clearly how I have existed. I see that everything I have done, everything I have thought, everything I have been is a kind of illusion and madness. I'm amazed I never could see it. All that I was, now at last I see, is what I am not. The light suddenly singes it all and consumes everything. It leaves me naked, far away from myself. It was all just in a moment, the smallest quintessence of time.
We're going to move into some more diary footage from Stanford, from SLAC, and this is an interview, a brief discussion with Roger Blanford, who's head of the astrophysics division now, on what is dark energy. It's just diary footage, and we'll see how it fits into the timeline.
Dark energy is a catch-all phrase for a variety of attempts to rationalize a series of observations which are now consistently pointing to a description of the universe wherein it is accelerating. So in some sense, if you think about the separation between galaxies, that is increasing at a faster and faster rate.
Yeah. Yeah.
And
is this is a surprise to find this?
Well, it is and it isn't. It is a surprise in the sense that if you ask people like me, what chance would you give that this be a fair description of what's going on? say 10 years ago, I think we'd have given it a low probability. If you ask, was contemplation of this possibility in the historical record, the answer is resoundingly yes. In fact, it takes us back to the very first attempts at combining general relativity and cosmology by Albert Einstein. His very first cosmology had in a term which he surprisingly recognized as being admitted mathematically, and therefore he refused to set it equal to zero. He included it as an effect, and his version of cosmology at that time was of a static universe. And he said, I will put something in there that will counter the effects of gravity, and oppose it with some sort of repulsive force that didn't have a counterpart in regular physics. And people have thought about that ever since. Mostly we sort of said, well, this is superfluous, let's get rid of it. But now it appears that something very much like this is part of our universe.
This next section is a reading of the poem Happiness by Borges by John Berger. I accompanied John Berger into CERN, and his suggestion was that this poem could not have been written before quantum theory, and he basically challenged physicists, the young physicists, to...
Whoever embraces a woman is Adam. The woman is Eve. Everything happens for the first time. I saw something white in the sky. They tell me it is the moon. But what can I do with a word and a mythology? Trees frighten me a little. They're so beautiful. The calm animals come closer so that I may tell them their names. The books in the library have no letters. They spring forth when I open them. Leafing through the atlas, I project the shape of Sumatra. Whoever lights a match in the dark is inventing fire. Inside the mirror, an other waits in ambush. Whoever looks at the ocean sees England. Whoever utters a line of Lydian calm has entered into panic. I have dreamed Carthage and the legions that destroyed Carthage. I have dreamed the sword and the scale. Praised be the love, wherein there is no possessor and no possessed, but both surrender. Praised be the nightmare, which reveals to us that we have the power to create hell. Whoever goes down to a river goes down to the Ganges. Whoever looks at an hourglass sees the dissolution of an empire. Whoever plays with a dagger foretells the death of Caesar. Whoever dreams is every human being. In the desert I saw the young Sphinx, which has just been sculpted. There is nothing else so ancient under the sun. Everything happens for the first time, but in a way that is eternal. Whoever reads my words is inventing them.
The next envelope is a piece of work with Derrida, Jacques Derrida, and we were discussing the question of ghosts, obviously not in the mystical sense.
Je voudrais vous demander une chose.
Here we go.
Est-ce que vous croyez aux fantômes?
Je ne sais pas, c'est une question difficile. Est-ce qu'on demande d'abord à un fantôme s'il croit aux fantômes? Ici, le fantôme, c'est moi. Dès lors qu'on me demande de jouer mon propre rôle dans un scénario physique plus ou moins improvisé, j'ai l'impression de laisser parler un fantôme à ma place. Paradoxalement, au lieu de jouer mon propre rôle, je laisse, à mon insu, un fantôme me ventriloquer, c'est-à-dire parler à ma place. Et c'est ça qui est peut-être le plus amusant. Le cinéma est un art, une fantomachie si vous voulez. Et je crois que le cinéma, quand on ne s'y ennuie pas, c'est ça. C'est un art de laisser revenir le fantôme. Alors c'est ce que nous faisons ici. Donc, si je suis un fantôme, c'est-à-dire si actuellement, croyant parler de ma voix, précisément parce que je crois parler de ma voix, je la laisse parasiter par la voix de l'autre, pas de n'importe quel autre, mais de mes propres fantômes, si on peut dire, à ce moment-là, il y a des fantômes. Et ce sont eux qui vont vous répondre, qui vous ont peut-être déjà répondu. Tout ça, c'est aujourd'hui, ça doit se traiter, me semble-t-il, dans un échange entre l'art du cinéma, dans ce qu'il a de plus inouï, de plus inédit finalement, et quelque chose de la psychanalyse. Je crois que cinéma plus psychanalyse égale science du fantôme. Vous savez, Freud, toute sa vie, a eu affaire au problème du fantôme. Voilà, le téléphone, c'est le fantôme. Je vais. Allô? Yes. 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 There will be a small seminar tomorrow afternoon. It's a kind of closed seminar, but you may come if you want. At 15 past 4 p.m. Salle des Résistants. And there will be another seminar on Wednesday, next Wednesday at 5 p.m. Yes, yes. Okay, I'll be very glad to meet you. Voilà. Alors, une voix fantomatique, c'est quelqu'un que je ne connais pas, qui aurait pu me raconter n'importe quelle histoire, qui venait des États-Unis, se présentant de la part d'un ami, etc., etc. Bon, ce que Kafka dit de la correspondance des lettres, voilà, la relation épistolaire, ça vaut aussi pour la relation téléphonique. Et je crois qu'aujourd'hui, tout le développement de la technologie des télécommunications, au lieu de restreindre l'espace des fantômes, comme on pourrait le penser, on pourrait penser que la science ou la technique laisse derrière eux l'époque des fantômes, qui était l'époque des manoirs, d'une certaine technologie fruste, enfin d'une certaine époque périmée, alors que je crois au contraire que l'avenir est au fantôme et que la technologie moderne de l'image, de la cinématographie, de la télécommunication décuple le pouvoir des fantômes, le retour des fantômes. C'est au fond pour tenter les fantômes que j'ai accepté de figurer dans le film en me disant que peut-être on aurait les uns et les autres la chance de laisser venir à nous des fantômes, fantômes de Marx, fantômes de Freud, fantômes de Kafka, fantômes de cet Américain. Vous, moi je vous connais depuis ce matin, mais déjà vous êtes traversés pour moi par toutes sortes de figures fantomatiques. Donc, je ne sais pas si je crois ou si je ne crois pas aux fantômes, mais je dis vive les fantômes. Et vous, est-ce que vous y croyez aux fantômes?
Certainement. Oui, absolument.
Okay, the next piece is very different in a way. It's extracted from the feature film Partition, and it is simply the use of the mirror, and only in cinema really can we use the off-screen space in this way, and the kind of time use in this way. It's acted by the actor John Shotton.
British graves in India. Who look after them now?
We could never have stayed on. You know, as well as I, that power without property can never last. In the New World, as in Australia and Southern Africa, our power came from our occupation of the richest lands and the obliteration of the inhabitants. Impossible to repeat that here. So now we're transferring our power to those with property. I don't want to go. No, in a curious way, I feel as though I have been taken over by India. Sights, sounds, smells, and the space. The space. England's an island. No real escape's possible. Suffocates me. I hate it. For a century and a half, we taught the Indians, rich and poor, to believe that we, Raj, were their mother and father. Mabap, a collective parent. So, why do I feel orphaned? When are you leaving? Look, I don't want to pry. I mean, if it's an intelligence business, keep it to yourself. I've been transferred to Malaya. The communists have unleashed a guerrilla war. I'm sad, very sad to leave this country. But the world is changing. First Malaya, then it'll be China. I fear it's all too late. History is against us now. Something in our non-comprehension of the way the world really is has blinded us to the turning of the tide.
When we try to improvise, what exactly are we going into? Is it possible to act freely, that is, without any relation to prescribed texts, And this next piece is part of a work that I was doing with Jacques Derrida on the basis of
l'improvisation. Qu'est-ce que c'est donc?
Ce n'est pas facile d'improviser. C'est la chose la plus difficile qui soit. Et même quand on improvise devant une caméra ou des micros, on se laisse ventriloquer et on laisse parler à sa place des schémas, une langue qui sont déjà là, qui sont déjà un grand nombre de prescriptions inscrites dans la mémoire, dans la culture.
Et l'improvisation, qu'est-ce que c'est donc?
Ce n'est pas facile d'improviser, c'est la chose la plus difficile qui soit. Et même quand on improvise devant une caméra ou des micros, on se laisse ventriloquer et on laisse parler à sa place des schémas, une langue qui sont déjà là, qui sont déjà un grand nombre de prescriptions inscrites dans la mémoire, dans la culture. Tous les noms dont nous avons parlé jusqu'ici, Antigone, Tiresias, Oedipe, sont des programmes. Ce sont déjà des noms qui nous empêchent d'improviser. On ne peut pas dire n'importe quoi. On est obligé de reproduire des discours plus ou moins stéréotypés, plus ou moins... Donc je crois à l'improvisation, mais je lutte pour l'improvisation, mais avec le sentiment qu'elle est toujours impossible. Mais là où il y aura eu improvisation, c'est là où je ne peux pas me voir, où je ne me vois pas avancer, où je suis aveugle à moi-même. Et ça, je ne le verrai pas, ou alors, mais l'autre le verra. C'est-à-dire ce qu'il y a d'improvisé ici, en ce moment, moi je ne le vois pas.
The next piece is possibly an improvised piece, which I was fortunate to be involved with Joseph Beuys in the 1970s, and this is one of the works that we created, semi or so-called improvisedly. from the felt board to the blackboard, and the next piece is a private tutorial, really, that was given to me by Michael Peshkin in SLAC. And he did ask if I wanted him to dumb it down. I said no, and these were the consequences. And we're going to be accompanied with this by a piece of back.
We have this theory called QCD, quantum chromodynamics. And QCD is basically a theory of quarks and gluons. So the quarks and gluons are, of course, the things inside protons, pions, etc. And we understand quarks and gluons extremely well. And in particular, there's a basic theory by which quarks radiate gluons by an interaction which is very similar to the way that the electrons radiate photons. The coupling here, which is called G sub s, is weak at small distances. This is this business of asymptotic freedom. The energy of the electron, K0, is much greater than the proton mass. So I'm going to ignore the proton mass, quark masses, and all of that in these calculations. That'll be good when the electron is extremely energetic. So then the center of mass energy squared is 2p, and let me call the proton 2p. Then we can define a quantity called x, which is equal to, in fact, we can also define 2p dot q, and we can define a quantity x, which is q squared over 2p dot q, and a quantity y, which is 2p dot q over 2p dot k. So these are both quite interesting quantities. X basically is a way of measuring the mass of the final state here. This momentum here is p plus q. The mass of that state is m squared is p plus q squared, which is equal to 2 p dot q plus q squared, which is equal to 2 p dot q minus q squared. So the mass of that state is determined by this quantity x here. So s is p plus q squared. T is the transfer q squared, which is actually minus q squared. And u is, sorry, please excuse me, k plus p squared. U is k prime minus p squared, which if you work it out is s, the same quantity as up here, times 1 minus y, where y is this quantity I indicated here. And t in particular is q. So in the end we'll get the following equation. d sigma dx dy is equal to the sum over all the various flavors of quark in the proton times x times f of x. So this is the up quark distribution for f equals up, the down quark distribution, also the anti-quark distribution. qf squared, and then that factors away from something that looks like pi alpha squared over over q squared times s times 1 plus 1 minus y squared. And there may be a factor of 2 in here. You have to excuse me that I forgot. And then we can look at a cross-section for a quark and an anti-quark to annihilate into a mu pair. And please notice that this is just a simple quantum electrodynamics process. kind of cross-section this way actually. Remember, is 4 pi alpha squared over 3 times the center of mass energy squared s, times, there's an extra factor that comes from the colors. Because quarks come in 3 colors, and a random color will come from each side. There's only a probability of a third that you're going to have this. So this is the quantum electrodynamics value, and there's an extra number, a third, which comes from the fact that the quark and the antiquark that annihilate have to be the same color, but that only happens 1/3 of the time.
Everybody will be tested on the way out, actually, so I'll make sure. The next piece is completely self-explanatory, a short poem by Fires, which is an extract from Partition, the feature film.
जो टूट गया सो टूट गया, जो टूट गया सो फूट गया, कब अश्कों से जुड़ सकता है शीशे का मसीहा कोई नहीं, क्यों आस लगाए बैठे हो।
We're moving into this last act, 3 considerations on light, the nature of light. The first is again from Milton, written I think in 1667 or something like that, around that time. And it corresponds also with Rembrandt painting The Blinding of Samson. The poem is called Samson Agonistes.
Inferior to the vilest now become of man or worm. The vilest here excel me, they creep, yet see. O loss of sight, of thee I most complain. Blind among enemies, dungeon, or beggary, or decrepit age. Light, the prime work of God, to me, is extinct, and all her various objects of delight annulled, which might, in part, my grief have eased. Inferior to the vilest now become of man or worm. The vilest here excel me, they creep, yet see. Oh, dark, 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 amidst the blaze of noon, irrecoverably dark, total eclipse, without all hope of day. O first created beam, and thou great word,
Let there be light, and light was over all. Why am I thus bereaved thy prime decree? The sun to me is dark, and silent as the moon when she deserts the night, hid in her vacant interlunar cave. Since light so necessary is to life, and almost life itself, if it be true that light is in the soul, she all in every part, why was the sight to such a tender ball as the eye can find so obvious and so easy to be quenched, and not as feeling through all parts expressed, that she might look at will through every pore.
Next piece is the piece that was shot at CERN and was projected onto the power station that Neil talked about earlier. Shot in the old accelerator at CERN with one light bulb.
Sein oder nicht sein, das ist die Frage.
Moving to the last of the segments, which is a short film about a camera of the future that shoots at 15 quadrillion frames a second, as far as I understand. This was shot in California at SLAC.
If you send a piece of chalk from the ground to the moon at the speed of light, it takes about 1.2 seconds to get to the moon, going at the speed of light, so it's very fast. If you send this piece of chalk from the ground to the moon and you stop it again at the speed of light, and you stop it after a femtosecond, it will just pass through a sheet of paper.
I worked in cinema a lot and we were shooting at 24 frames a second. After 18 frames a second you can't really see the strobing of the picture. As you know, it's one frame of the picture, then one frame totally black, then one frame picture, then one frame totally black. So 24 frames a second means that you're only getting 24 48ths.
10 to the 15 frames a second is 10 to the 15 zeros after. So this is a completely different scale of machine. But I think the principle is the same.
When you increase camera speed, you get a shorter picture. You're peering into timescales that are inconceivable to the mind, but they may be a pointer to the kind of camera in the future.
Stretching out towards the Pacific over there is the 2-mile-long linear accelerator SLAC. And this accelerator basically can send down bunches of electrons at very high energies. Now, one thing we've learned about electrons is they do not like to go around corners. You make them go around corners and they protest. They protest by, in fact, releasing energy as they go around corners. The energy which they release is in the form of X-rays. And this energy we call synchrotron radiation. People realise that in actual fact this radiation that's coming off could in fact be the most incredibly useful tool, because the wavelength of this radiation is very low, and thus by putting things in its path you can see into things at the molecular level.
When you get down to the very smallest, then you begin to see separation of timescales. So there are phenomena that you will simply average over for a particular integration time or shutter speed. But if you could shorten the shutter time, you begin to see that, but at the expense of never really being able to make the film long enough to see the longer terms.
This is what the time itself.
Right. That philosophical question has certainly been asked. Funny thing about quantum mechanics is that in quantum mechanics that there's no need for that ever. One thing you never have to quantize is time. Time has a different property than particle numbers, spin, all the material aspects. Even light is quantized into photons, but not time. Time has very, the really deep fundamental thinkers in quantum mechanics admit that time is a rather odd bird.
Now what undulate does is create a whole series of artificial bends, one after the other. And so when we push these electron bunches, remember electrons like the straight and narrow, we make them go round a tremendous number of very tight bends, and they express their displeasure by releasing X-rays.
It's kind of interesting to think about what happens when this bunch structure goes through something like this.
Right.
Every one of these lines of electrons produces radiation. And here's the interesting part. At the same time, the electrons are kind of going on this wiggly path, so they're not quite going the speed of light. And every time they go through one cycle, the electrons have gone slower than the light by exactly this distance. And that's what creates the coherence.
So what's flying out at the end is like a machine gun fire of very intense X-rays. That we point at the sample we want to study, whether it be a biological sample, chemical sample, and these X-rays hit the sample. In comes they can see the very, very small dimension at a very small but also, because they're coming in so fast, as these samples change, buzz, hums and vibrate, we are able to film these changes because the shutter speed essentially coincides with the rate of change of the activity that's going on. The intensity of the X-rays is such that when the X-rays hit the sample, they destroy it. They just blow it up. And so it seems somehow contrary to common sense that you build a machine which blows up the thing you're trying to study. But before the sample is actually blown to smithereens, we have sufficient time to extract all the information we need.
The reason that we wouldn't really want to go below nanoseconds is simply that eventually we freeze the motion of electrons, and the things that are moving even faster than that are deep within the nucleus. They're not chemical things, they're part of physics.
In a sense, they'll be beyond reach at this point.
It would be beyond reach physically, but it would also be beyond interest chemically. So it would be of interest to nuclear physics and high energy physics, but you would no longer learn things about chemistry on that time scale. Everything just didn't have the natural time scale. Now, is there a fastest natural time scale? Part of this is have this unification time, Planck time, which is so much faster than anything we're doing. Now, is that a time scale below which nothing interesting is happening? Well, no, there's not. We have no way to access and answer that question. And it would be a very interesting challenge to find a way to visualize all that at once by having some kind of logarithmically increasing progression in time scale, and at the same time teach us how to derive insight from it.
We don't just have perspective. When the first guy invented the movie camera, but he could never predict how that one instrument was going to have an influence on society. To describe units of time smaller than a femtosecond. Atoms is the next one there, and I'm sure eventually we will reach that. But in some ways, the femtosecond is the important regime, because we know that this is the speed which biological and chemical processes take place.
This short epilogue, the poem by Seferis, the Argonaut, spoken by Seferis in the 1950s, is really to try to emphasize and underscore the idea that this journey of human culture is a long journey and is a collaborative journey, and the journey hopefully will continue. Jamil Reyes on the percussion, Kieran Maguire on viola, Jack Maguire on violin, Arquiles on the sound mix, Phil Petrides on the projection, and with great thanks to the research teams and the administrative teams at the university behind this event. Thank you very much.
Ladies and gentlemen, live cinema, Ken McMullen, thank you very, very much. There is another drink outside. Ken is going to be very happy to take questions. So again, thank you very, very much for being here tonight.